Good day, learners. This time, now proceed with the second case of variation, which is inverse variation. In this lesson, you will learn the following: illustrate situations that involve inverse variation, translate into variation statement a relationship involving inverse variation between two quantities, and solve problems involving inverse variations. So what is inverse variation? Inverse variation is also called inverse linear variation or indirect proportion. It is a relationship between two variables x and y such that no matter how the values of x and y change, their product is constant. In symbols, y varies inversely as x is written as y is equal to k over x, or k is equal to xy, where k is called the constant of variation and where x is not equal to 0 and k is not equal to 0. Terms like y varies inversely as x and y is inversely proportional to x are used with the same meaning. For two quantities x and y, an increase in x causes a decrease in y, and vice versa. A proportion can also be used in relation to indirect variation when solving problems where some quantities are known. The following proportions are two several proportions that can be formed. We have k is equal to x sub 1 times y sub 1, or x sub 1 y sub 1, and k is equal to x sub 2 y sub 2. Then x sub 1 y sub 1 is equal to x sub 2 y sub 2, or it can also be written as x sub 1 over y sub 2 equals x sub 2 over y sub 1. That is, if we divide each side by y sub 1, y sub 2. Let's have an example. Find the equation and solve for k if y varies inversely as x and y is 6 when x is 18. For our solution, first, we have to translate y varies inversely as x into equation. We have y is equal to k over x. Then, we substitute the values of y and x in the equation, where y is 6, x is 18. Therefore, we have 6 is equal to k over 18. Getting their cross products, we have k is equal to 108. For the equation of the variation, in place of k, we write 108. Therefore, we have y is equal to 108 over x. Let's have another example. If y varies inversely as x and y is 25 and x is 6, write the equation that describes the relation. Find y when x is 15. For our solution, we translate y varies inversely as x into equation. So we have y is equal to k over x. Next, we substitute the values of x and y in the given equation. Therefore, we have 25 is equal to k over 6. Get their cross product to solve for k, or for the constant of variation. So k is equal to 150. For the equation of the variation, we have y is equal to 150 over x. Now solving for y, when x is 15, we'll have y is equal to 150 over 15. Therefore, y is equal to 10. Another way to find y when x is 15 is by using the proportion x sub 1 over y sub 2 equals x sub 2 over y sub 1. So by substitution, we have 6 over y sub 2 equals 15 over 25. Get their cross products. So we have 15 times y sub 2 equals 25 times 6. 15y sub 2 is equal to 150. 15y sub 2 equals 150. Divide both sides by 15 to solve for y sub 2. Therefore, y sub 2 is equal to 10. For our third example, a journey takes 8 hours at 60 kilometers per hour. How long will the same journey take at 70 kilometers per hour? So in this particular problem, we can actually use the proportion r sub 1 over t sub 2 equals r sub 2 over t sub 1. By the way, r is for the rate and then t is for the time. And in this problem, r sub 1 is 60, t sub 1 is 8, r sub 2 is 70, while t sub 2 is unknown. By substitution, we have 60 over t sub 2 equals 70 over 8. We get their cross products. So we have 70 times t sub 2 equals 8 times 60. 70 t sub 2 equals 480. We divide both sides by 70. Therefore, t sub 2 is equal to 6 and 6 over 7 hours. Next example. The intensity of light from its source varies inversely as the square of the distance from the light source. If the intensity of light is 120 units when the distance is 3 meters, what is the intensity of the light when the distance is 5 meters? So for our solution, we use the proportion I sub 1 over the square of b sub 2 equals I sub 2 over the square of b sub 1. In this problem, I is for the intensity and d is for the distance. So by substitution, I sub 1 is 120 over the square of d sub 2, wherein d sub 2 is equal to 5. I sub 2 is unknown, while d sub 1 is 3. Therefore, we have the square of 3. Then, we have 120 over 25 equals I sub 2 over 9. Get their cross products. So 25 times I sub 2 equals 9 times 120. Which will give us 25 I sub 2 equals 1080. Then, to solve for I sub 2 or the intensity of the light, we divide both sides by 25. Which will give us 43.2 units. Now, for your activity, answer the following. Thank you and God bless.